Hello friends, this is my third video and here I'm going to show static structure analysis in ANSYS. First I draw a design in SolidWorks software, and then after I put this design into the ANSYS. Okay, here you can see this chair. We do the static structure analysis of this chair. Here first we select the material in engineering data. Here from here, engineering data sources, then we click on explicit material because the chair is in the PVC plastic material, so we choose this one. Okay, explicit material is open, so here you can see different kinds of the material is available, but we have to choose the PVC plastic. Sorry, I forgot to tell you, this PVC material is not available in explicit material, but it's available in the composite material. When you click the composite material, then it's open the PVC form. Okay, so from here we add this material and we find this material into the geometry. Okay, then back to the geometry. Here you can see the geometry is open. So from here we import the part, import external geometry. I tell you how to import the part from design software to the ANSYS in my first video. So you go for this video and watch how to import the part. Here I am used the step extension. Here you can use also the IGS, another step extension. Okay, so okay, open. It's a frozen mode, so we have to add the material and generate. It's take a few time. Okay, it's open. Our chair is open, which is we shown in SolidWorks software. Then we go back to the model. Here you can see the model part is open and the processing is done. Yes, here you can watch the chair. Okay, so here we have to do some analysis step. So first we have to put the material, and we put the material into the engineering data which is available at here. Okay, so you click the new chair and then you find the material at here, assignment material. So here you can select the PVC form material. Okay, here the stiffness behavior you have to put into the flexible. If you put into the rigid, so analysis will not complete if you put the rigid. Okay, so we have to put the flexible. Then after we have to do the meshing. Mechanical engineer who very well know about the meshing. Okay, the meshing is done. In my second video, uh, in my first video I told about this meshing, and in my second video also proximity and the curvature. This is the different kinds of the equation or the different kinds of the method to put the meshing into the any design part. Okay, let's we go to the analysis setting. Here we have to compulsory and add the step and time. Here we put the 5 e raised to minus 3. We put the little bit time because it consumed the less time to do the analysis. Then here we apply the force, because the people sit at here, so we apply the force at here. We apply the maximum force at here around 300 kg. Okay, and our chair dimension is 1 foot, 1 foot, and at the below side is 1 foot. Okay, so chair is not big, it's a 30 centimeter this side, centimeter 30 centimeter is this side, and 30 centimeter is this side. So it's a 30 by 30 centimeter chair. Okay, so here we have to choose the component, because you can see it here, the y direction is in downward side, so our the body weight is totally into the downward side, so we have to put the force into the y direction around 3000 Newton. It's approximately the 300 kilo, 300 kg. Then we have to put the fixed support, because when we sit on the chair, so at that time the bottom side is fixed, so that's why we have to choose the fixed support and apply. Then we have to go for the solution, in which we will see the total deformation, equivalent von Mises stresses. This is the von Mises stresses theory. Okay, here solution, we apply the solve. The process is done. Here you can see the total deformation which is available at here. So look at this. If the 300 kg man is sit on this chair, so what kinds of the result will be achieved by us? Okay, so look at this, the deformation in the chair. Okay, stresses, the maximum stresses is generated at here, this side, because the at here the low material is available at this point. Here from the prop we can see better 14. Here you can see the 14 is maximum, so here you can see the 40 is maximum 14. Here you can see 14.031 megapascal. Okay, here the stresses is normal up to the 1 megapascal. The maximum stresses is at here, at here. Okay, let's see what kinds of the deformation is available here. You can also generate the report of this whole analysis, and you generate also the copy from here. Look at this, all this stuff you can see it here. Even in the graph we applied, you remember we applied this end time 5 e raised to minus 3. Okay, geometry, here we can see the total deformation. Okay, you see the isometric view. Look at this, how to our chair is deformed. Okay, here the material is lower, then the chair is deformed very high. If the material is good, so our chair is deformed, not deformed in this way. Here we see the equivalent stress. Okay, thank you so much, and please subscribe my channel and share this channel. Thank you so much.